So, let's start the second session this morning. And the first speaker is Kimyeong.
This part. Even finally, we have a copy. Yes, I have to go there to one.
So let me start with this one technical organizers, local organizers, what is working case. So I'll talk about complete prepotential of 5 spoken word cases. This work is on progress and hopefully appear in the month. Work from this Hayashi, Hayashi, Song-Soo, myself, and Toshiaki. So we've been working together on 5 comfort cases for, I don't know how many cases we'll be writing, but this is an additional thing we have recently. Right, so roughly I'll review 5 spoken word cases, and then I'll introduce complete prepotential. Before that, I will remind you what is the prepotential of 5 cases, and then I will conclude. So 5 spoken word cases has been discovered almost now 20 years ago, more than 20 years ago by Nazi Cyborg. Where if you look at the 5D Yang series, or higher general Yang series, usually it's non-minimal, so it looks like you'll be incomplete. Naturally, one expects you can complete theory in 10D superstring series, like heterogeneous string series, with very specific kind of group, gauge groups. But 5 or 6 theories, you can usually complete the theory without introducing gravities and strings. Rather, for example, 5D n equal 1 super Yang series, they with the SU2 gauge group. And also, when fundamental hypermultiplet has a UV fixed point with enhanced global symmetry, which is include EN type exceptional gauge group, which is includes SO2 and flavor symmetry, and also additional U1 global symmetry arising from instanton solitons. Instantons in 4-dimensional space is the Euclidean time solution, which indicates a tunneling return between different vectors. However, in 5-dimensional series, in 4-dimensional space, there is solitons, PPS solitons, and its mass is related to inverse of coupling constant. And because the instanton number is topological, there is conserved charge, and also there is conserved current, which is basically proportional to this term current. And so there is conserved U1 charge, U1 global symmetry, and then there's SO2 and flavor symmetries. They merge into a single exceptional global symmetry. And this theory has a superconformal group F4, which is the exceptional supergroup. Now, interestingly, this number of flavors can increase from 0 to 8, and then Boris and Cyborg found the additional theory with the SU2 gauge groups. For example, SU2 gauge theory with no flavors can have 2 types of theories depending on the discrete theta term related to pi 4 of SPI and SU2. And also there's a non-Lagrangian theory of rank 1. You can get it by decoupling the flavors, or decoupling the by making a flops. And so this is the appearance of, say, non-Lagrangian theory in 5D spoken word physics. So in rank 1 theory, roughly is given in terms of these classifications. So of course we know E6, E7, E8. So for example, if we have 5 flavors, it has 6 global symmetries. But when you reduce the rank, this E0, this notation for the exception groups. And also now, if we include 8 flavors, then the theory doesn't go to UV fixed point in 5D, rather it goes to 6D E8 string theory. It's 5D 1,0 spoken word theory with E8 global spectrum. And it becomes 6D theories. So, for example, the simplest theory with SU2 gauge group is one without flavors. There are 2 types of theories which can be seen from very easily from PQ fibrine webs. So this SU2 gauge group with discrete zeta term 0, and this theory with discrete zeta term pi. And then you can see that theory between deep fibrine segment is theory on deep fibrine is SU2 gauge theory, and the W boson is fundamental string connecting them. Instanton is D1 string connecting NS fibrines. And if you make a S transformation, then you are basically extending NS fibrine to D fibrines, which is extending W boson to instantons. And that's why T theory has a global symmetry SU2, where SU2 biosymmetry is extending basically W bosons and instantons. On the other hand, when the zeta term is pi, there's a W boson, but because of this tilting, you can have PQ string webs, but there's no instanton without electric charge. So there's no SU2, there's no S transformation, S0 transformation, which means that it's SU2, U1 instanton global symmetry is not enhanced to SU2 global symmetry, it remains as U1. So when you have these theories, one of the key to is the Nekrasov partition function, which is basically, you do basically, if you look at the theories, there's this PQ string web connecting LS fibrines, and they are basically dionic instantons in field, and you are trying to count their index with various chemical potentials related to their angular momentum and the global symmetries. So angular momentum chemical potential is epsilon 1 and epsilon 2, which is omega formation parameters. And then this partition function on alpha cross S1 can split into perturbative part and instanton parts. So instanton parts sort of one instanton, 2 instanton contributions, and 0 instantons. And basically they are counting massive charge in column phase, they are counting massive object, which is BPS. So perturbative part, key contribution is W bosons and also massive hypermultiply. Now, there's other way of counting, which is called the topological vertex. But when you have this partition function, you can put it in some form, plastic exponential form, and then this prepotential free energy can be exponential free energy can always expressed in terms of plastic form. Then this single particle free energy is basically counting single center the PPS diode instantons. So when you count that, there's a natural quantity appearing, something called Kopak-Buffer invariance. So the way you do expand the partition function is in terms of number of electric charge. So A is Coulomb parameter of SU2. And so power of E to the minus A is the counting amount of electric charge this PQ and one of dionic instanton is carrying, and Q is the instanton numbers. Interestingly enough, when they did this Nekrasov partition function, which I will show just a little bit later on, this group of people found that the natural expansion parameter is not electric charge, rather shift of electric charge with instanton charge velocities. So with this shift, natural expansion is A theta. And with this very particular power of the NF dependence, which you will see very natural later on, with that, one can expand this partition function, which is made of perturbative and non-perturbative part, and then one can put it into very simple form, where this free energy is given this pressed form with a single particle free energy. And this U and B is basically omega deformation parameters along the epsilon minus and epsilon plus is like epsilon 1 and epsilon 2 is 1, 2, and 3, 4 rotational chemical potential on R4. And then this single particle plastic exponent, this single particle free energy has a simple pole over, say, 1 over epsilon 1, 1 over epsilon 2, which Nam talked about yesterday. And then, so this one counts the basically center of mass motion of a single BPS object. And then this J plus and J minus is counting internal angular momentum over diagonal instantons. And A tilde is counting basically total dependence of the photon parameters. And then chi YL is basically made of the flavor chemical potentials, and then also instant chemical potential. Remember, in UV fixed points, global symmetry due to flavor and instanton merging together. So that's the YL. And so we'll see more specifically what this form is. And then interestingly now, the coefficient appearing in front of this counting is non-negative integers. And this is called alpha invariant. It's basically you have a dynamic instantons with a lot of electric charges and instanton charges and angular momentums and global flavor symmetry. And then you give all the quantum numbers, and then this number basically counts how many degeneracy it has. It could be 0, 1, or -2. So this is an amazing number. So let's look at the examples. So if we have a perturbative part, there's free hypermultiplet, and there this internal angular momentum is given by this with the external fermionic and bosonic contribution. So if it's 0, 0, then it's hypermultiplet. 0, 1 half is vector multiplet. So this, so what is called this angular momentum count is 0, 0 is 1, -1, 0, 1 half is B plus B inverse. And so this one covers the perturbative hypermultiplet plus instanton contribution to hypermultiplets. And this contributes to perturbative vector multiplet plus contribution from the instantons. So if you look at, for example, SU2 is 5 flavors, then there are SO10 flavors, SO10 global symmetry. So this E6, 5 flavors, E6 global symmetry, so they merge into 27 bars. So 10 coming from perturbative part, and then 16 bar coming from single instantons, and 1 coming from 2 instantons. So together their contribution forms a hypermultiplet, which is 27 bar over E6. Now, vector multiplets, W boson, there's only one. So SU2 broken to U1, there's one W boson coming from single perturbative part. One instanton gives you 16, and 2 instanton gives you 10. And then coefficient is 1. So this is a single particle free energy, so there's hypermultiplet with 1, 1, and so on. So this is a very precise way of counting ionic instances. But to see this enhancement of global symmetry, you have to really work hard to calculate Nekrasov partition functions and so on. But now we have a much more simpler way of looking at this kind of thing using complete prepotentials. So IMS prepotential is obtained by interrogating Morrison and Seibel in '97. So suppose I have a gauge group in 5B n equal 1 theory, where SU as gauge group is broken to U1 terms in Coulomb range. So for example, Chern-Simons term can be used for SUN gauge groups. So suppose SUN is broken to U1, then you look at the prepotential. So prepotentially, you have a kinetic term, and then there's a Chern-Simons term. Now, IMS prepotential is quadratic in these Coulomb parameters, and it just is one exact. So all the W bosons give you these contributions, and then all the flavor symmetry gives you these contributions. So this has been extremely useful quantity people have been calculating. But if you look at these quantities, you haven't included any instantons. So this prepotential is manifestly invariant on the SO2n flavors, but N0, which counts is inverse of complete constant, counts the instanton numbers. On the other hand, the flavor, MF is flavor, chemical potential. So you see they are completely different objects, and somehow prepotential doesn't capture the enhancement of global symmetry. And we managed to put M0 and MF, which looks very different from each other, into a single context. Right, so IMS prepotential is cubic and the one we expect, and it's valid in small gauge coupling regime, and you do one calculation. On the other hand, like E0 theory is non-Lagrangian theory, so there's no W bosons. You cannot do one calculation, so it's a hard calculation to do. And also, the IMS prepotential has been used to calculate the magnetic monopole swing tensions, which is BPS, and also there's a coupling constant depending on the quadratic derivative of prepotential. But enhanced global symmetry is very fast. So we are proposing addition to IMS with some additional terms, such a way total prepotential is complete. It has it is valid in all the plot transition from peak to swing perspective, and also enhanced global symmetry is manifest, and also it has many more nice properties. And we confirmed this complete prepotential using many other technologies. So let's look at the SU2 is NF flavors. So there's a classical term. SU2 theory doesn't have a Chern-Simons term. So this W boson contributions, and that's flavor contributions. And then we introduced some new technology. We introduced absolute value, W absolute value of F is zeta minus F times F. So that's non-zero when F is negative. And also we introduced this A theta, which is turns out to be invariant of the global symmetries. So we are shifting A by this quantity. And so ordinary absolute value for perturbative part from W boson flavors can be expressed in terms of ordinary one with this W absolute. And it turns out this is related to Renol, which is quite used in AI. Recently, I realized this has been introduced in AI. So then you have additional Coulomb parameter made from flavors and zeros. So let's look at the SU2 case. It is a single particle of Mavapine period. And even though there's a one W boson, this W vector multiply, there's one W boson, but there's an instanton contribution which is additive to each other. And so one can express this one in terms of this 2 over global SU2 is made of, after this shift is instanton minus a half instanton and plus half instanton. That's the character of the two-dimensional representation of SU2. And this is manifest on the invariant of the SU2 global symmetry, where Q inverse is shifted on the Barré transformation. Now, question is, can we do that for prepotentials? So for prepotentials, here is the prepotential, here is the classical part, there is one part. But with this shift, we can see that this prepotential is, here we don't need to improve it. It's complete by itself. Here is the cubic terms, then there is quadratic terms. But remember, Q inverse is the Weyl transformation. And you can see this prepotential is, once we use this invariant Coulomb parameters, m going to minus m, this is quadratic, so it's invariant on the global transformation. So m going to minus m is like, usually in gauge theory, if we have a coupling constant 1 over g square going to minus 1 over g square, it's total disastrous, right? We never change the sign of the 1 over Yang-Mills coupling constant square. But in 5D, you can do that. Just going to negative coupling is like rotating the sun by 90 degrees. And under that, you haven't done much. So theory is still constant. And that invariance can be seen from the prepotential people, IMS prepotential, already after this shift. So prepotential has many roles. So it has W boson contribution, beta contributions, but also we want to have this enhanced global matrix. So let's look at the more complicated case. So SU2 is NF equal to 1, single flavors. And then this here is supposed to be SU2 close to U1 global symmetry. So you look at the IMS prepotential. So there is classical part, there's one loop coming from W boson, and then contribution from single flavor. And N1 is the flavor mass. So you can express this in terms of values. So double absolutes, you can express it this way. And if you look at this, it doesn't have SU2 cross U1 global symmetry because N0 and N1 are completely independent of each other. I cannot flip it. So we have to introduce additional term by hand. This quantity we introduce by hand, and then we justify this right by many other method. So once we introduce this term, and then after shift away by this invariant A tildes, you can express this in terms of this universal algebras in bench forms. And then with this expression, you can see SU2 cross U1 global symmetry is manifest. Because U1 part is Y, so you don't change the flux. But X is going to minus X is basically SU2 by transformation. So this quantity is just introduced to just make this complete potential to be invariant on the Y transform of this global symmetry.
Kimyeong, is this equal or you add it?
Adding, so right.
So not equal.
Not equal. Sorry, right. Right, so we add it by hand, then we justify. So the way to justify is you go to interesting wave diagrams, then you do a lot of plots. Remember that complete superpotential is valid in after all the plots. So we want to justify this term is valid on all the plots. So one of the things is that this interesting maps, now you can do the S transformation is rotating this one by 90 degrees. So you are making it D5 to NS5, NS5 to D5. You can see this diagram is more or less invariant. And then you change through all the parameters, and then you calculate that 90-degree rotation is leaving the Y to be invariant and the X to be changing its sign. So it's just, this is the S transformations. Right. So once we do that, then we can chase through the E2 with one flavor to SU2 is set equal to pi to non-Lagrangian theory by various decouplings. So we look at these diagrams where M1 is negative, then there's a webs of string, and as we reduce the Weyl transformation, this is a U1 theory, and then I reduce it, and this is a U1 theta theory. I reduce it, Coulomb parameter, it becomes E0 theories, and we can follow through all these flops from prepotentials. So we can go through that U1 theta. We go through the flaps, and then we get the E0 series for prepotential for E0 series. And everywhere global symmetry is manifest. So this looks like a very obvious exercise one can do. Now, so one can do either, you can get from E2 to E1 also, so you can do the plot, and then you get the answers, right? Now, okay, that's a little warming up. Now, let's go to SU2 with 7 flavors, which is EA global symmetries. And this is IMS prepotential coming from 7 flavors. And then this, I use the ReLU to use 7 flavors, and there's bare terms. Now, if you look at it, this one is again not invariant on the EA global symmetry. It has SO14 global symmetry. So we add terms, a lot of more terms, to make this one to be 248. There are only 14 terms. But if you look at the Kotakuma there's a pathology part is 14. Then you have to add all these higher instanton number contributions. And so we add all this to make it EA global symmetric, by reflections and all blah blah, and then you get a 248 contribution to this pathology part. And then this series is obviously invariant on the EA global symmetries. Now, you can justify this many ways. One is, again, you can go to PQ5 brand maps, and then you calculate the monoprotensions and all that, and then you can see indeed that this prepotential is right contribution when you go to right parameter values. You can go to the 5D conformist field theory can be obtained by compactifying M theory on collegiality space, and then you can do geometric calculation of prepotential, and we get the expression we have. You can compute Kotakuma alpha invariant and prepotential. Then from prepotential you can get a 4D R focus as on prepotential. Then from which you can get a 5 prepotential. Again, you get the same expression we have. So they all match together.
So is the complete prepotential reduced to the usual IMS prepotential?
Right. Right, of course. IMS is part of the right. So in parameter rating, IMS is part of it. So if you look at higher rank as P2 plus NF equal to 9, you complete prepotential is not just made of the part. You have a SO20 adjoint, SO20 vector contribution, SO20 spinor contribution, and the rank 5 antisymmetric contribution. Only when you include this is a complete prepotential. So you have to use Weyl transformation, you have to do SPO transformations. You have to do a lot of work to justify.
But on the other hand, if you just look at the IMS prepotential, it's not clear what kind of the global symmetry we have a priori.
No, and you don't have any of these.
Yeah.
Other than if you do there's a dual test series. Using dual series, you can judge what kind of terms will be there, some of it. So for example, this theory, there's dual description, there's bifundamental description contribution, and they contribute to part of this very fancy contribution. So you have to use all kinds of tools to justify this complete prepotentials. So for example, this case, we have complete prepotential, and then you have this kind of contribution to prepotential. Where 30380 is one of the dimension of the representation. And one can do a lot of other checks. So to complete prepotential includes all the transitions and also theories. We also know what contributes to this additional term. It comes from the previous hypermultiplet, which flops when you do change the parameters, and they contribute to the prepotential. And this series is invariant on this S invariant, not only on the flavor symmetry but other symmetries, which I don't have time to talk about. And they provide the additional tool to calculate 5D and 6D superconformal fields. It's a little string series, and it's also great simple tool to calculate. I mean, this is infinitely easier than Nekrasov partition closure. Thank you.
Thank you very much for explaining us
Does your final answer contain Nekrasov parameter?
No. Oh, so it's much simpler way of testing many.
I see. So it's
Any other question?
The addition of this prepotential
Right.
the instant fractions.
It's instant, but I mean, there's no. I mean, M error is there, but it knows a lot more than I mean. It knows much less than Nekrasov partition function, but it knows enough to manifest the global symmetries and also SGL invariance. So, for example, some of 5D theories, L3 KB series 1007 is due to G2 KB theory. Both of them are same UV fixed point, and again, this complete prepotential gives a very natural way of going back to these two transformations.
How about the other question, comments? Okay.
All right.
So, please time. Well, last speaker of this morning session is Professor Diana Park, and he's going to talk on exploring self-geometry theories in 6 dimensions.